All right. I guess we already have a discussion going on here on the stage, so we might as well switch on the microphones. And everybody's still having coffee, you could join us. So I would like to start off the panel with a question that that somehow is often asked by public media, asking about fabrication is how far is this from reality, and when will we be seeing these things in actual built environment, and how will the cities look like when all of these new methods and materials that we're developing are put to use?
Is this on? Yeah. Well, I always tell people that the buildings we are starting to design now, or infrastructure or whatever, they're not going to be built within 5 to 10 years from now, probably. So I wouldn't be surprised if we very shortly start designing projects with printed products in there. The other question, in which way it's going to influence the world around us, I think is a completely different question, and that very much depends on both the designers, whether they're coming up with new designs that can only be made with additive manufacturing, for example, or any of the other techniques displayed today, or whether we run into problems where additive manufacturing or digital fabrication is the only solution. So it could be short term, it could be a bit longer term, I guess.
I think it's probably about, is this on? Yeah. I think it's probably about what type of processes and what part of the industry. I mean, obviously right now there's a lot of robotic work that's been done in terms of prefabrication in factories, which is then brought to site. But I think the critical question, as you're saying, is like, how does it actually change what we do? And I suspect it'll only be a very small group of people who are actually initially changing what we do. And whenever there's new technology, that technology is typically just reapplied to replace an old technology and to produce old things. And the example I always use in lectures is that is the first iron bridge. There was an iron bridge that was built in 1780 something in England, and it's a radical new material in a way, like using metal to build a bridge for the first time. But it's detailed like a timber bridge. It looks like a timber bridge. It basically could be a timber bridge, except it happens to be made from metal. And this is what generally happens. And so I think we can see that with 3D concrete printing now. That's happening mainly in China. There's a lot of 3D, well, a lot, there are several people who are doing it, who are producing, multiple buildings which are 3D printed out of concrete. And these look like every other building. Like, you couldn't possibly tell it's 3D printed. So I think it often takes a long time for the industry, like the construction industry, but also for designers. I think a lot of the conservatism actually comes within our profession. Like, we want to just keep on replicating what we know. And so I think the onus is on us to figure out what can you do with these new technologies, which is radically different to what you could do. And obviously steel bridges now are radically different to timber bridges, but it's taken, it takes a while to get there.
Yeah, I mean, that's a good point, and something similar can be seen, for example, in industries, now talking about the perspective of the fiber composites. It is being used in, for example, car industry, but they use it often in a way how they were used for their metal processes before. Like there's this term called black metal, where they just say, okay, we use the same processes, it's just a little bit lighter. They don't really incorporate the material characteristic and think the whole process from the beginning, which is understandable because there's this giant pipeline behind it. And for architecture, it's even worse because there's no industry. Yeah? That's actually the point. Like, we need to produce these things ourselves because no one else could do it. That opens two opportunities. Either you get, as an architect, you get back a bigger piece of the cake. Let's say it was, okay, I'm designing this, but I'm also making part of the specialized fabrication for the composite parts. Or there needs to be industry that develops once there's a demand and opportunity for the project there. But for now, for example, with our wood project, it's much more easy to bring that into the industry, because milling wood is not an unknown thing. It's just if you do it in a slightly smarter way, people are open for that. With the composites, it's really like some steps further, I would say. Yeah.
I think the useful thing to understand is that the technologies we're using and the materials are not in any way new. I mean, industrial robots have been around since 1953. Fiberglass was developed, I believe, during the Second World War. The first fully fiberglass, fully composite house was built in 1957. I mean, we're actually using things which are somehow like actually quite old. It's just that they've never really been pushed to their limit or really fully explored. And maybe this is something worth discussing. Like, why is this the case? Why is it now that there's a group, I guess a group of our contemporaries who are interested in these materials? I suspect it's got something to do with its relationship to computational design. We're all now involved in designing geometries which are extremely hard to make in the current building paradigm. So we're obviously looking for other possibilities that we're taking from automotive or aerospace industries, boating industries. And what's your take on this? Why has it taken so long, and why is there suddenly a kind of intensive interest in it now? Yeah, anyone?
Yeah, I totally agree. It's the same for additive manufacturing. It's been around since the 80s. And I've been thinking about that, and I do think that computational power and software tools that allow us to come up with designs that we can prove digitally at least work and could be built. We have that possibility now, but we often were forced to simplify our digital designs in order to prepare them for fabrication. And I do think that computational design has stimulated everyone to look a little bit further to actually be able to build what we designed.
Maybe I add a little bit. I think there's also trust between industries. Like fabricators do not usually trust architects because the drawings. Hello. The drawings don't work, or they don't understand the geometry, so they add this extra cost just to redraw things what is presented them as a sketch. So these things add up by time and by cost, and I think if we get better communication between fabricators, builders, designers, I think that also drives down the cost just by trusting each other.
But there's a relationship between technological innovation and then kind of culture and cultural values, and it takes so many stakeholders to make great buildings happen, or just to make buildings happen. And I think that a part of the kind of the agency of technology is in its ability to change the culture within which innovation, architectural innovation is possible. And so it's the culture of the discipline of architecture and the allied disciplines, right? So there's the first layer, which is disciplinary, like why are architects doing this or not doing this? Then the second one would be the industries that are connected to those technologies that allow for architecture to be delivered in those terms. And then there's the kind of the broader culture, the stakeholders, like the great clients, the public that want certain buildings. And so I think that many of us are involved in teaching, and I think that in a way this issue of experimental practice, it's not only about this kind of direct translation from prototype to building, but also a way of shaping the culture within which the kind of architecture that we care about happens.
Yeah, I totally agree with you on the culture side of it. We're getting to a point where, or we have gotten there a while ago, where digital design has matured to a level where there's not that much you can do in the virtual realm anymore. All the possibilities pretty much have been explored, and at one point we have to start moving beyond digital and connecting to the physical world, which I think at the moment is the biggest challenge: how to connect digital design to actual physical processes.
Yeah. Yeah, I would agree, and I think that a lot of that's we're seeing over the last couple of years within experimental architecture a lot of push towards real-time robotics, and I think this is going to be the key. I think because right now we're either encoding material behavior within the algorithm, or we're imposing the algorithm upon material. I think soon as we continue, or we're really just starting off this development of real-time robotics, we're able to actually bring a closeness between material behavior and algorithmic behavior, which I think will perhaps address some of that.
Mm-hmm. Similarly, in Salome's project, you really think a 3D printer can do anything, especially if it's in a case of powder. I mean, there's nothing that can fall off, but it still has limitations, and the actual means of production change the way you design objects.
Yeah, absolutely. And if I can add to what Raoul and Igor said before, it's not only the architects that maybe are doubted sometimes for their knowledge, it's also the engineering firms that don't always have the best link to real building. So we know how to calculate, and we know how material behaves, but we don't often get our hands dirty. And I think now what's becoming really interesting is that all of a sudden our digital output, the product we normally deliver, is being fed directly into the machine. So that's a huge responsibility. So all of a sudden we need to be much more knowledgeable on not only production techniques, but also the actual production of products and how different variables influence that and the quality of the products. For me, that's super interesting, but it also requires my colleagues to gain a lot of knowledge and experience. But I personally only think that's a good thing, but it narrows the gap between design and production, and I guess also allows to look at the integration of different variables in a more holistic way, making or sort of hopefully leading to a more optimized result.
I think we have a question in the audience. Can we get a mic?
Hi, guys. Thank you so much for your presentation. So I will make a bit of trouble, but friendly one. So I think a couple of people already reflected on the kind of connections between the earlier paradigm of 1990s, which is the use of 3D modeling to come up with new non-planar geometries, and then how isn't this wonderful that 3D printing now allows us to build it. And I guess I want you to think a bit deeper about it, right? Because exactly the fact that it looks so natural is problematic, right? So 21 years ago, Greg Lynn introduces Alias to Columbia Architecture School. It starts paradigm 1, right? Because Alias didn't have doors and walls, people start making complex geometry. So that's already your fathers have been doing it. Now your generation comes in and says, oh, great, where's 3D printers? We can actually now print complex geometry. But it's a bit too easy. Why not use 3D printing to make perfect 19th century buildings? Why not use 3D printing to make perfect cubes? Like, for example, there is this building outside, right, which was put like in 3 hours in front of our eyes. It's not 3D printed, but in many ways it's much more innovative because we took a sail and we pressed it into the concrete, and you get this incredibly interesting central surface. So my point is, obviously you are on a cutting edge, and that's wonderful, but I think that this kind of slippage, right, from paradigm 1 to paradigm 2, and the fact that this kind of complex aesthetics becomes the default aesthetics of 3D printed architecture, it's like a bit too easy, right? So what if we kind of try to do something very different? And maybe there are already examples I'm not thinking about. Maybe let's say you're printing 3D house, which is just a cube, but what you're actually printing is holes for sensors inside, right? So things like that. So any reflections?
I'm happy to answer that. Okay, so there's quite a few bits to the question. On the first one, why wouldn't we build perfect cubes, or why wouldn't we build neoclassical buildings? I think as architects, I mean, particularly perhaps as young architects, I think we have a responsibility to try and figure out what is the architecture of our time. And I think we need to respond to a contemporary intellectual discourse and intellectual context. I mean, for example, my work is concerned with primarily with complexity theory, which is a very different way of thinking about formation and the way things come into being in the world. And I'm interested in designing through those mechanisms. So I'm not about to design something of a previous paradigm if this is the way I understand the world. So that's one intellectual argument as to why you might design in a certain way. I think another one is why wouldn't you build a perfect cube? Well, I mean, a cube is, apart from being a certain type of geometry which has a kind of cultural understanding, we build cubes typically because we have sheet material. I mean, material comes in sheet form. If material is not coming in sheet form, then it probably doesn't make sense to build a cube. A cube is structurally not very strong. It's not very efficient in terms of material. Like, there's ways of 3D printing things which are much more, dare I say, organic forms, which are far more efficient. So even if you're just going to make a pure argument about efficiency, there's no way you'd 3D print cubes. So, and to tackle the a third point of your question, I think I appreciate you saying the geometries that we're dealing with, in a way, at least have their basis in the work of Greg Lynn from 93. Yeah, I think all this work is not possible if it wasn't for the work Greg Lynn was doing in the early 90s at Columbia. And I think some of the work that's happening in the contemporary sphere, it's people who are taking those geometries and trying to figure out how to build them. And when they do it, some of that work is not altering at all. Like, it's still the pure geometry that's driven by modeling techniques and certain algorithmic approaches. I think some of the work that's happening here is not quite like that necessarily. Like, I think that if you look at something like Moritz and Akim's work, they're very directly saying what is the behavior of material and what is the fabrication technique. And I think, that's my understanding of your work, is that's actually what's driving the forms. It's not being driven by a software side thing. And I would probably make the argument about my work that's a bit of a feedback between them. So part of it is driven by an interest in these expressive qualities of algorithmic design, and then part of it is driven by what is the behavior of materials and robotics. So it's sort of a feedback. But I don't know. You guys probably all feel fairly strongly about that question. I mean,
yeah, I guess it's that's also an understanding of form that's very not driven from the contemporary design theory and processes. So when we say that now our design is much more based in the expression of the material behavior and the fabrication strategies, of course you can build a cube, but that's really only based on, I don't know, a purely aesthetical judgment of the thing, and it's not really developed from the core of the construction strategy. I agree with the sheet material approach, but even nowadays with a sheet material, you would rather do a segmented shell structure, for example, if you want to use the material in an appropriate way. But it's true that a lot of these biological analogies are used in a far too superficial way. So a lot of people are alluding to that loosely, but don't really transfer the inherent capacity of these structures. So there's not a process of understanding, abstraction, and transfer, and also an understanding that these technological transfer then later might look really different from what you actually saw in the beginning in your biological role model. Yeah? Often it's more like a mere aesthetic analogy. So that's why, I don't know, like there's a lot of talks of architects where biology is somehow used because it's nowadays fashioned. Yeah?
So you consider yourself a purist in this way? Like, it's something almost religious in the way you describe this, right? So it's like, it's almost like that there is something inherently of value or right about what's in nature, and therefore the most pure transfer of that into architecture is important.
Yeah, so it's about the functional principle, yeah? And the new aesthetics come along with the way how the tools and the materials and how you apply them get implemented. But it's not about an aesthetic transfer, but it's about a functional transfer from biology into construction.
Well, I just wanted to add one other thing, just a comment about the kind of foundations of architecture as a discipline. There's a whole kind of history of the discipline where that's, of course, about architects drawing, not building, right? Or, I mean, in today's paradigm, we could say that maybe it's a drawing, maybe it's a script. But in any case, one of the disciplinary projects for architecture is to always forge relationships between techniques of production in the architect studio, so things that architects do, and techniques of construction, fabrication, making that make those propositions or speculations possible in the real world. And so I think that that's one of our disciplinary responsibilities, is to maintain that relationship between those two sets of processes. And so it's a part of the reason why the kinds of tools that we're using in the virtual realm, let's say, or in our fabrication studios while we're prototyping, are also then reflected in what kinds of instructions we make for the buildings that need to be made out there in the world.
Just a very short footnote. So you guys done very well, you pass. But just a little footnote. I mean, I think obviously we're all interested how to define a logic and aesthetic, architecture or art for our time, which is different from previous generations. But it's a very difficult question, right? So people mention the word efficiency, which I think is still taken for granted. This is a concept from 1860. Engineers were defined as people who were efficiency expert in 1860. So that's a very modern idea. That's a very old idea. Complexity theory, as you know, it's 1960. So it's also a very old idea, right? So how to be contemporary, really contemporary, right? It's very, very difficult, and I think the only way to do it is to question every single concept you'll be using. So keep going, but just a footnote. I mean, it's very hard to do, right?
Yeah, I think the question of aesthetics is a very interesting one, because a lot of times it's argued for through structure or some mathematics, or I don't know, engineers using algorithms to optimize structures might say it's more honest, or this is the way the materials perform. But there's always an algorithm that is written by a human being that is actually curating the way the system can behave. It's never endless possibilities. There's always some kind of curation in the process. And I think that's where, like, you can never argue for, like, there is no ultimate truth. So there's always some kind of aesthetical kind of author's intent embedded.
Yeah, if I can briefly comment to that. I think there are just many ways of aesthetics, many levels, many ways to look at what is the right solution or what is beautiful and what is not. And to also briefly respond to the gentleman's comment, for me as an engineer, not an architect, it's just important that people are honest about it. It's fine for me if you make a bridge that looks like a butterfly wing, but if it just the looks instead of the structural idea behind it that actually resulted in the butterfly wing, then I like that to be communicated. So if it's a Renaissance facade on a Chinese printed house that's just glued on there, that's fine if that's what the goal was at that moment, but it's not a Renaissance house. And so I think there are many different levels, but I'd like to be open about it at least.
Yeah, I think it would be a misconception to say that algorithms replace the designer in a way. Yeah? Just the level on which you design just shifted a bit. It's like more like a meta design. You design the algorithm, you design the boundary conditions which need to get resolved. You can tweak some parameters. You get offered a variety of options that would all be somehow feasible. And then, of course, you still decide to go for the one versus the other one. Yeah? So it's more like a meta design. Yeah.
There's kind of two issues here. One is the issue of abstraction, like how close you are to the thing that you're designing. Are you directly designing it, or are you setting up the conditions from which something emerges? But then the other one is about a reliance on pseudo-objectivity or whether you embrace subjectivity. I firmly believe that architecture is part of the humanities, not part of the sciences, and that's the position I take. And given that, I believe that all the decisions that we take in our projects, which are highly abstract in terms of their generative process, are entirely subjective. I would never defer authorship in any way to something which I believe to be objective. I would never defer authorship to something which is numerical, which is the only way a computer can possibly evaluate something. I would claim that everything we do is subjective, even if it operates through a highly computational process.
If we just thinking about typical conversation with architects, so if there is aesthetics, there is my aesthetic, your aesthetics, and we need to come up with a conclusion, like what to do. It's like actually a very hard part of our discipline to agree on anything. It's like there's no objective layer, or like sometimes people come up with this pseudo scientific or pseudo other reasons to prove their project is better than the third one. And it's kind of there's a certain honesty. You just tell I like it. That's why it should be like that. Or you think there is something else.
Well, I don't think that subjectivity is randomness. I mean, one's judgment can be quite sophisticated and layered and conditioned by many things. And so I don't think that subjectivity means I like it or I don't like it, but that there are some of judgments and decisions that one makes along the way, right, towards as a means to some goal.
I think it's absolutely. I agree with you. And I think it's this liking it or not is based on an incredibly nuanced, often, hopefully, very well argued set of reasons for something. But those reasons can't be quantified. They're all qualitative. And I think part of this is because all the things that we really value in architecture are actually qualitative. None of them are quantitative things.
Criteria for subjectivity. Yeah, right.
No, it totally exists. And I think part of this, you alluded to this idea of like, how do we discuss these things if there's no objectivity? I think part of it comes down to, are we trying to create an architecture which is something that can be disseminated and almost develop within the mainstream, or are you interested in making an architecture which is esoteric and individual and strange and personal and unique? I think when I first started doing the work, well, not even when I first started, probably if I've spent 15 years working on this multi-agent algorithmic behavioral formation project, if you'd asked me 5 years ago, I would say that I was trying to establish a way of design that could be disseminated, that people could pick up and start working with this as a tool. And now I begin to realize that none of those things are things that I care about. The things I actually care about are all the kind of unique, strange, esoteric qualities of the projects we're doing. To me, they're things that are really important. They're actually the things that I think resonate with people. I think the way you design something is, outside of yourself and the academy, it's entirely irrelevant.
I think what we kind of do is we develop our own vocabulary, and one of the part of the vocabulary is how we achieve this vocabulary is through code. But it's like, I feel like the challenge is not to solve everything with the same tool, but how do we merge things together? Like, I mean, this building here. There's a metal work, there's a stone work, there's concrete work. They're all different tools to make these things. So how do we make this come together again? Like we develop something unique, and then we start using things from the old and new and some others. And I think this communication is going to be quite challenging for next decade.
Yeah, if you're talking about the building, I think the sort of layered approach that we're having now, where each functionality has its own layer, I think that's also outdated. We're already looking into that.
I mean, if you look your node, I mean, you didn't invent the cables again. Like, I mean, that's what I think. It's just that it's not like layered, but I think it's there's a place for a different method for fabrication for a different task, structurally, functionally. We can't just solve with the same tool everything. Like a 3D printed house is the kind of, I can't say stupid idea, but I think it's just a little bit immature to think like we do one method everything. We haven't done anything with the one method.
It's a part of the reason why we could probably all agree that there is this kind of circulation of pavilion architecture that we've all been a part of, that's possible and that's actually highly productive as far as research goes, but that of course is not an indication of everything that goes into a building of another scale, right? So you can still deal with not necessarily forms that are monolithic, but a process that's monolithic, right? Where one or two things can maybe do the work that is a part of the kind of proof of concept or an exploration or an experiment or whatever, however your practice is framed, but that very quickly in terms of more conventional long-term buildings, you would encounter composite conditions, details, climate, and that and none of those things can be resolved with a single set of tools.
Yeah, that's actually true. But I still think that, as you said, the research pavilions are a really interesting tool to foreground one research agenda and push that further, while other aspects can be a little bit taken back. But I also think there's the urge, or really the need, to before this robotic frenzy, let's call it, like everyone who does a robot, it's fancy, is over, to turn that into one thing that has really like a valid, that can be really implemented, and that's really important to make that to that point, to make that leap. And I think that I mean, things that we're currently addressing is functional integration. How can, for example, a lightweight structure that doesn't have any thermal mass be thermally activated, for example? How can, while you wind the fibers, be small pipes integrated? How can sensors be integrated? So how can a building skin be integrated? Those are all topics that need to be addressed, of course, step by step, because it's like you're really rethinking the whole thing from the bottom up. But I think those are really important steps. Rather than jumping from one pavilion to the next fancy thing, there needs to be a little bit like a continuation of development, and only then you get the chance to actually implement it later on. And also the design argument, one thing is also that it's, of course, it's very technology and performance driven, but ultimately we also expand the design repertoire. Yeah? We explore novel tectonics, material articulations, characteristic, also light atmospheres, how the glass fiber is, guiding the light. All these things are also really valuable in these explorations. Yeah.
I think a really important aspect of that is, and I totally agree with you, is that these technologies or techniques are hopefully there to expand the space of architectural design possibility. And I think that's what I see them as all inherently experimental, because they're opening up new space in which you can explore. I just want to go back to the first part of what you're saying, where are we moving too quickly to actually ever be able to realize buildings at a larger scale? Like, it's not, I can make a pavilion and I can craft it myself. But I can't make a building this size myself. Now, I could start up a construction company to try and do it, but I'm probably not going to do that. But I don't think I could find a construction company to build the things that I'm designing or build the things that I'm prototyping. So if we're developing really, I guess, if we're exploring and developing robotic forms of fabrication, are we actually just causing another problem for ourselves in terms of that technology transfer, even if it's quite possible. Like, it's quite possible, right? We can say, look, I've got some robots, they can do something. I can demonstrate it can work. Now, why don't you just go and buy some robots and start making my buildings for me? I mean, it's quite possible to say that, but it's probably not going to happen. I mean, I can think of one example where it has worked well, which is the Gramazio-Kohler model of the brick, where they've developed the bricklaying technique. Then they basically gave it to a company, the IP, and that company now is able to build their buildings. What's the strategy? I mean, what do you guys think? How serious are we about getting these things out of the lab and out of pavilions and into this scale of building? And if we're to do that, what has to happen?
But isn't it as simple as just finding the right clients? I mean,
no, I don't think it's the client. I think it's actually the construction industry. We have to find the right people who are willing to take on these technologies.
But that's what I'm saying. I think if there's a client who wants one of your designs actually built on a scale like this and willing to pay for it, I'm sure there will be a contractor actually willing to build it.
Well, I guess in my experience, I mean, I'm not building buildings this size, but I'm building small buildings. And in my experience, I can develop techniques in the lab which I know I can build very cheaply and efficiently. But I can't find anybody in industry who's willing to actually take that IP or that R&D and actually really construct it. So consequently, what I end up doing is designing simplified versions of what I want, which then still cost way more to produce than the techniques we would have used in the lab. So my experience has not been that. My experience has not been the clients are willing to build these things, but actually finding fabricators who are willing to do it is extremely difficult.
But then you're asking them to adopt the technique, but also maybe the design part. Don't you think that if you have a client and a design, and you're just looking for someone to actually build it, would they still choose the most expensive technique? Don't you think there would be anyone willing to look into what you developed in the lab?
It's about risk, I think, ultimately. As soon as contractors are doing something they don't know how to do, there's inherent risk in it for them. Yeah. And it's actually, this is the real problem, ultimately. Yeah. I mean, risk is probably the ultimate problem just in general. It's like the risk of the contractor, but more so actually the risk of the designer. Like, you know, we're probably all more conservative than we think we are. And it's like architects are not willing to take risks, fabricators are not willing to take risks, clients are not willing to take risks. And that perhaps that's the reason why some of the things that we imagine aren't as possible as we would like to believe them to be.
Yeah. Well, and maybe it also depends on the technique, but with additive manufacturing, for us, for quite a long time, the contractor part, so the builder part, who was responsible for the end product, was a bit of a gap. But actually, there are a couple of contractors in the Netherlands, especially, standing up, really trying to present themselves as the most innovative contractors, totally looking into additive manufacturing. I'm not sure if I'm pretty sure they've never actually done it, but they're telling the whole world that they will be the ones to do so. So I'm going to keep them to their word and build something as soon as possible.
I'm afraid we have to wrap up soon. Are there any questions from the audience?
Okay, so it's not me. It's a question from Apple Messenger, because I was communicating with my friend from Michael Sorkin office about the panel, and she wants to ask like 2 questions. Seriously, no, very good ones. So, yeah. So first, okay. So this question from a friend who works at Michael Sorkin office, and now it's early morning in New York. So the question is this still a one-off? 3 points. Is it still one-off? And then the second question was, ASIAs are doing 3D fab interesting. Question is, can they scale it up? So I know you guys already started addressing it, but I think one-off question hasn't been addressed as much. So.
I think architecture is always a one-off. I mean, often a one-off, let's say. You need to find individual solutions for the specific task that you have. That's actually also the problem why you can't transfer techniques from industry for serial production. So easily, if you want to have a very specific solution to your architectural problem. So ideally, it's a one-off. And the scaling up is a really big issue, specifically referring back to, for example, the biological structure. Scaling is always like a really big boundary. Half of the stuff that's interesting, you can't actually use it because it's not scalable. That's a very important aspect you need to be aware of. And we are currently having various parallel research projects running which are about scaling the technologies I've shown up into large scale, either in situ monocoque fabrication or close to site large component fabrication. Those are bigger than you could actually transport. They are only manageable to put together on site.
Just to add, I think you asked like, how do we get off the lab and get to the real world? I think what you're doing is one of the things, like you continuously do one thing and develop it as a product, or like as a solution product or service product. And I think that's one way of getting closer to industry and adaptation. In one point, you probably could potentially wrap it up as with a company or something who can provide the service. But I have a question which is kind of aesthetical. How do you actually pick the final pavilion shape and textures, and who makes this decision, and how this decision process is usually in your office, or is there gonna be one meeting, or is it you saying like, well, that's it, we go for it, or like time is up, we need to pick up the shape and start doing it, or how can you a little bit open up the background on that front? Usually it's I feel it's a so dense moment when somebody needs to start doing it, and then there's these discussions, and like who's saying is like which way, and
yeah. I think the two pavilions I've shown were a little bit. They had different procedures how that was made. The first one had exactly the situation that you said. We developed a computational tool, we tweaked it, we worked on it, and somebody said, okay, that's good enough. Write out the code, get the robot running. Otherwise, we don't make it in time anywhere. So that's why it's really, like you mentioned that before, what is sometimes called honest by people. Yeah, it's really rough, like fresh from the oven onto the machine. With the second pavilion, we had a really interesting and really nice catalog of fiber layouts that would, most of them would have worked less or better. And there we had a longer discussion about how can we actually highlight the qualities of that structure. So how can you actually have interesting gradients and densities, and how can this fiber characteristic be nicely articulated. So there's a little bit of both. I would say it's really coming from the algorithm, but then there's still a discussion about.
I think
you have multiple people in the problem who makes the decision.
Sure, yeah. We have a group of core research associates who are developing the project, and then there's a larger team. And then, of course, we have regular meetings, we discuss it, we develop the code together. Yeah.
I think the easiest way to answer that question is every single step is a design decision that leads to it. Like, I don't think it's something which there's a process that's set up which is somehow autonomous, and then out of a plethora of potential outcomes, one is chosen. I think it's just a constant process of design decision and refinement. So every time you write a line of code, that line of code has got design decisions based in it. I think every time that you run an iteration, you change a parameter, you change an input, all those decisions are guiding it. So I don't think we really select something. I think it's almost like, I think it's more like craft. You're just constantly fine-tuning something, and it's almost like a block of something you're whittling away at. You're slowly crafting the thing to get it to be the point that you want it to be. I think sometimes this assumption about algorithmic design being a field of possibility that you search through is not quite the way it really operates.
Yeah, I mean, the same what you're mentioning for the digital is also true for the physical fabrication. Like, while you're designing your tool, you're designing your design outcome as well. So basically...
And feedback between those things.
Yeah, exactly. So it's not a technical task, okay, now I built a tool and later I see what I can design with it. But while you make decisions on how this tool is arranged, you make design decisions along the way. Yeah.
One thing enables the other, right?
We need to understand our tools better. We need to make decisions while creating our tools. And we need people that are willing to take risks, I think, to get these things out of the lab. Thank you very much for this panel. You can take a risk and become an e-resident of Estonia. And with this, you can then connect. And
yeah, it's a little, just a little bit of explaining. It's a little, these guys are our sponsors. They're Estonian designers who designed the world's smallest ID card reader, which you probably know about, the Estonian people in the whole, the Plus ID. It's pretty cool, pretty beautiful little tiny thing. But yeah, we're about to wrap up the symposium. Are you guys ready to continue on to the Architecture Museum and then continue the discussion, but in a different venue?
Right.
But anyway, I'll just take a minute to say the last few words, before we all continue with the other events of the Biennale. First of all, I would like to say that when we started thinking about this, the 2 intense days, I think it's the shortest major event of the Biennale, right? Out of the all major things, the symposium is only 2 days, but it's super intense. It was super intense these 2 days. I think we had a lot of diversity. We had a lot of discussion, which was exactly the point of this specific symposium, to have different views, different topics, different approaches, illustrate the diversity of architectural landscape that we actually have. So I think that was probably a success. Do you agree? All right. Good. Yeah, the second most important thing, apart from accomplishing the mission, so to say, I think are the thank yous, and there are a lot of those. First of all, obviously, to the audience who actually came here. And then today I learned a pretty amazing thing, that we watched the direct stream yesterday of the first day of the symposium was watched by multiple thousand people, which for an architecture event I think is pretty damn good. Yeah, awesome job, all the listeners and participants. Then obviously the speakers, but the speakers are also tied to our team. So the biggest thank yous are to the team and to the speakers who actually made it across the ocean from Australia, from Japan, from the United States, from all over the place. Huge thank you to you guys and to all the speakers who are still around. A round of applause. And obviously, the symposium wouldn't have come up the way it did, or it wouldn't have happened without the team behind it. And I don't mean the curatorial team, which is myself. I mean the team of TAB, the Italian Architecture Biennale. Because the reality is that most of the speakers whom you've seen during the last 2 days were invited by our other team members, not actually myself. Even the space that we find ourselves in right now is actually the TAB Lab space, which is a whole different exhibition, who was kind enough to loan it to us for 2 days and actually made the event even more awesome than it would have been otherwise, just considering how the spaces worked. So a huge thank you for TAB Lab for being around and setting up the space for us. And also the TAB Club, which is right next door, right? Because I found that a lot of people like to just kind of, they would come here and sit in the conference format. They would go to the TAB Club and just kind of chill and, listen in, but at the same time work. So I think this, the venue is just superb this year. We should definitely continue it next time with the same, the same venue, the same place. But another little thank you is obviously to our sponsors, because somebody needs to pay for the show, right? So a lot of thanks to the sponsors. Just a round of applause for those. All right. So the next thing I wanted to say was that we shall publish all the speeches, all the talks, and probably all the discussions as well on the Estonian Center of Architecture Vimeo channel, just so you guys know. Plus, those of you who registered at the door when you came in, we collected, if you wanted to, you left the emails. So we're going to send, once that stuff is ready, once the whole post-production thing is done, then we're going to send links and information and follow-ups to those people who provided their information to us. And the last thing that I want to say is that we have a pretty dense day today. For example, in just 15 minutes at 5:30 in Tab Club starts the discussion of the vision competition that was opened yesterday in Viru. The discussion is going to take place right there, right, with all the winners and the jury, I assume. So you can go ahead and check that out. Then at 7:30 opens the main exhibition in the architecture museum, right, Seem? I guess so. So yeah, please be most welcome to come and join us for that, because it is the main exhibition and all of these guys are participating, so I think we should totally go there. And then after that we have a gala at 9 o'clock and then the party back here in the Tab Club at 2300. So everybody with the passes, please come and join, hang out, talk, continue discussions, and just have a great time. And just from me, thank you so much to everyone again for listening, for participating, even for asking questions, those few of you. Yeah, see you later. Thank you very much.
Thank you, Ivan.